Meet Connor. He doesn't have any friends, although he is subtly trying to make friends with a boy named Benton. Recently he has been having dreams with themes of physics. Meet Benton. Benton has lots of acquaintances, but no real friends. He also has been having dreams of physics.
What kind of resonator is that, Mom?
It's a closed pipe resonator.
Hey, Benton! Almost right. The clarinet is a closed pipe resonator. According to this article I just read, closed pipe resonators resonate only when its length is an odd number of quarter lengths. Like 1/4, 3/4, and so on.
Whatever, Peter. I'm going to bed.
But wait, Benton, wait! I'm getting our races off Saturday and Sunday! And I have gymnastics meet next Monday, and I'm ranked 112th out of 113th. That's my personal best! Listen to me! But wait, Ben, you're forgetting about open pipe resonators, such as the saxophone. Open pipe resonators can only resonate when there's an even number of quarter wavelengths, like 2/4, 4/4, and so on.
Okay, Peter. I'm going to bed.
Goodbye.
Well, Snickers, looks like it's just you and me again. Are you Old Man Doppler?
Yes?
I was told to come see you in one of my dreams.
Well, what was the dream, boy?
Well, I have a feeling that it was about 20 degrees Celsius, and I was sitting stationary on the sidewalk, and I feel, rather I have an inkling, that a vehicle passed me going about 35 meters per second. And it was honking its horn the whole time, and the horn was at a frequency of about 400 hertz. Now, the frequency seemed to change while the vehicle passed me. Why is this?
Well, it seems that you had a dream of the Doppler effect. The Doppler effect can easily be represented from this equation. FO equals Fs times 1 plus or minus the velocity of the observer divided by the velocity of sound divided by 1 minus or plus velocity of the source divided by the velocity of sound, where FO is the frequency heard by the observer and Fs is the frequency of the source.
In using the Doppler equation to find FO when Fs equals 400 Hz, VO equals 0 meters per second, V equals 343 meters per second, Vs equals 17.5 meters per second. Since the vehicle drove past Benton, the velocity of the source is divided by 1/2, making it 17.5 meters per second. One would then plug in the numbers given into the correct variables in the equation. One would then just use algebra to solve for the rest of the equation.
How's your day, Brian?
Whoa! Sound level too intense.
So, Brian, I was wondering how your day was.
Whoa, whoa! Sound level intensity is way too small.
How's your day, Brian?
Good.
Alright.
That was intense!
Intensity is the amount of power of the sound wave in proportion to the area of the surface, which is also represented by the equation I equals P over A, and is also represented by this diagram, which shows intensity at different distances.
The velocity is the speed of the wave. The wavelength is the distance between the troughs on the wave, while the frequency is the number of troughs that occur on a given period. This is all represented by the equation V equals lambda f, where V is velocity, lambda is wavelength, and f is the frequency.
Fascinating! 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 Yay!
Loudness is the attribute of sound that depends on the amplitude of the sound wave. As the amplitude increases, loudness gets greater.